Here we're looking at the fractional distillation of crude oil. Now in the last video, just a few pages earlier in the book that we're using here, we talked about crude oil as being a mixture of different hydrocarbon fractions. Okay, so the purpose of the fractional distillation of crude oil is to separate crude oil into its component fractions. Okay, a fraction is a compound. So here I've got a list of all the fractions of crude oil that we need to know for GCSE. So crude oil has some dissolved gas in it, it has some petrol in it, it has some kerosene. Kerosene is jet engine fuel. It has diesel in it, it has fuel oil in it, it has bitumen in it. Bitumen is road tar. So crude oil is a mixture of all those fractions. Now, before you can use crude oil, you have to separate it. You cannot put crude oil in a car's petrol tank. Crude oil is very viscous. It would simply jam it up. The car would never work again. However, if you separate it and get the petrol out, it makes the car go extremely well indeed. So crude oil is a separation technique. It is a separation technique. And we studied these separation techniques in year 10. Okay, so there's no chemical reactions involved, it's simply just separating the mess that is crude oil. So how does it work? It works because the different fractions within crude oil is a mixture of liquids, so fractional distillation works. Now you're probably thinking to yourself that this doesn't look anything like the fractional distillation apparatus in the lab. Fractional distillation apparatus in the lab is a batch process, so in other words, we put the crude oil on the bottom, we heat it up, and we can separate it out using the fractionating column. But then when the original flask is empty, we have to start again. Well, this is a continuous process. This is what they do in industry. So crude oil is continually going in there. This is crude oil liquid. So crude oil liquid is put into the distillation process continually. So it comes out of the pipeline from the oil field where it's being drilled out of the ground. It's continuously fed into this. And the fractions, the bits that make up crude oil, after they've been separated, come out here and then they're taken off to petrol stations, or the kerosene, that's jet engine fuel, is taken off to the airport, or whatever else continuously. So this works 24 hours a day, 7 days a week. So the crude oil liquid goes in there. How it works, it's heated to start with. The crude oil is heated until it boils. Okay, so down the bottom here, we're going to put an explanation about how this works. That's going to be our first point. The crude oil is heated until it boils. I've said use the word evaporate here, but I think boiling is probably better, but I'll put evaporate in bracket if you like. In other words, it turns to a gas. The crude oil is heated until it boils, evaporates, turns to a gas. So we have crude oil gas coming out of the apparatus here. So it's crude oil liquid going in, and then when we get to here, this is crude oil gas. Let's put that little note in there. That's crude oil gas, just there. So it's liquid here, it's boiled here, it's not burnt. That was wrong. No, it's just heated, and the liquid is boiled, like putting water in a kettle and turning it to steam. This is crude oil liquid coming in, this is crude oil gas coming out of there. Now this part of the apparatus here is a cooling tower. Okay, so there's no more heating done now. We just allow the hot gases to cool down. So let's say that next. The hot gases are then moved to a tall cooling tower. Okay. Now, hot gases rise up. Hot gases rise up the tower. And as they're rising, they're cooling down. So it's 400 degrees at the bottom, we've said that there, and at the top of the tower, it's cooling all the way to 150 at the top. Okay, so hot gases rise up. And you know this because if you put your hand above a Bunsen burner, it burns you. Okay, because the hot gases rise up from the hot flame. So the hot gases rise up the tower. The hot gases rise up the tower. And cooling. They're cooling the whole way until the temperature cools to the boiling point. Now this is the important bit. The boiling point of a fraction. Okay, so now if you remember back to the other page, the longest chain molecule in crude oil has the highest boiling point. So the molecule of the longest chain is bitumen. Bitumen has about 40 carbons in it, H82. 40 carbons in the chain. So the hot crude oil gas is coming out here, maybe about 400 degrees. And then, so maybe even a bit higher, 420 degrees, say. And let's say the boiling point of bitumen. The boiling point of bitumen is 400. Okay, so it's 420 degrees that comes out here, so it's gas, and the hot gases rise, so it's 420 maybe, and then it starts to cool down, 410, 45, 44, 400, so it's 400. At 400 degrees, we're at the boiling point of bitumen, So if we were to put a camera in the tower there, you would see it raining bitumen, okay? In the same way, in the sky, in the atmosphere, there is gaseous water gas. Okay, but when it rains, that gas turns back to a liquid and the rain drops down to the ground and soaks everything. Well, if we were to put a camera in the tower here, we would see it raining bitumen, we would see it raining road tar. Now, hot gases rise up, but hot liquids fall down. So as it rains bitumen, it falls out the bottom of the tower and it comes out the bottom here as a liquid. This is bitumen liquid. Okay, and that happens at the boiling point of the fraction, the bitumen. Okay. So let's write that in down there as well, shall we? When that happens, that fraction condenses and turns back to a liquid. So when that happens, that fraction turns back to a liquid. Okay, that liquid then drops, okay, I say rains because I think you can picture that, but don't write rains here, drops out of the tower. Now, everything else in crude oil at this point, is still a gas because the temperature is still hotter than the boiling points of all the other fractions. Okay, boiling point of fuel oil, let's say it's 370 degrees. Well, it's about 400 degrees here. So it still rises and it still cools. So 400, 390. At 390, say, the gases pass through these one-way traps. Look, if you look closely, you can see there's a hole there. So the hot gases can rise up through that, but then they hit this lid, if you like. Now, the lid isn't connected, so the hot gases come to the side and then round and keep going. Okay, but at 370, so it's cooled down now, 390, 380, 370. At 370, fuel oil's boiling point is at 370. That turns to a liquid and rains down. As that rains down, as it drops down, that fuel oil, it bounces off these lids, so it can't go back to the bottom of the tower. And it runs sideways until there's a way out of the tower there. So fuel oil liquid comes out there. But every other fraction continues to rise up because it's still a gas. Okay, and it goes through a series of these one-way traps and the whole way up the tower. Okay, so let's try and put something about that down. Number 6. Okay, the other hot gases carry on up the tower. The other hot gases carry on rising up the tower. 7. As they rise, they pass through one-way traps. Okay, I think then we've got an explanation about how crude oil is separated using distillation. Let's just fill a couple of these other things in. So as we go up the tower, some bitumen to fuel oil to kerosene to diesel to kerosene to petrol to gas, the boiling point decreases. Okay, so you need to know these trends in boiling point. And the reason of that is because the length of the hydrocarbon chain also decreases as we go up the tower. Okay, so the longest chain is at the bottom, the shortest chain is at the top. Now, the next page, we've got a table just talking about that type of thing. So what we need to do is we need to know a bit about each fraction, its chain length, its boiling point, its uses, things like that. So the fractions, right in order of boiling point I've written here. The fractions are on that last page now because they're here as well. So we've got gas, petrol. So we're going to go in this order. Gas, petrol, kerosene, diesel, fuel oil. Now you need to know this order really. And bitumen. Bitumen is road tar. So we'll put the uses there straight away. Bitumen is road tar. Fuel oil, power stations. So oil-fired power stations or ships, something with really big boilers. It needs a big boiler to set this fuel oil on fire because it's not very flammable because it's got a long chain. Power stations or ship boilers. Okay. Diesel, lorries and cars. So lorry and car fuel. Kerosene, jet engine fuel, not propellers for aircraft, jet engine fuel. Okay, petrol, car fuel, very flammable. Okay, sports cars use petrol because it's more flammable than diesel. Gas, heating and cooking. Heating and cooking, we use it in the home for those things. Very, very flammable indeed. Okay, so approximate boiling points. We've got the boiling points on the last page as well, so less than room temperature, so let's say less than 25 degrees C. Petrol, we've got petrol there, about 150 degrees. You don't need to learn these boiling points. The only thing I want out of this is the boiling points rise, okay, as the chain length increases. So you don't need to learn those. 400. Let's put that there. Okay, don't learn. Okay, number of carbon atoms in the fraction. We don't need to learn this as well. We just need to learn the trends. But so I've got rough figures here. So what you need to be learning. Okay, so gas. The fractions that make up gas have between 1 and 4 carbon atoms in them. Petrol between 5 and 10. So what you need. C5 to C10. What you need to learn is as we go down the tower, the number of carbon atoms increases. C15 to C20. C20 to C25. C25 to 35. And then over 35 carbons. Viscosity trend. So as we go down the tower, the viscosity increases. As we go down, okay, viscosity increases. Okay, as we go down, they get less flammable. The ease of ignition decreases. Okay, so don't learn the numbers for these, learn the trends. That's important. And that's what we need to know about fractional distillation of crude oil for GCSE.